All right, so here we go, guys. Agile Minds. We are at topic 2, multiple representations in the real world. This is student activity sheet 3 in the section exploring what's in a rule. Okay, so if you think back to our problem with Anthony and his dad, Mr. Chen, okay, Anthony, if you remember correctly, came up with the equation that the total number of tiles he would need is the same as saying 4 times the length of the side plus 4 corner tiles. So this is Anthony's, okay? Anthony. Okay, so he brings this, his models and his equation to his dad and his uncle. His dad is like, great job. But uncle, Uncle thinks of it a whole different way. So instead of the 4 sides plus the 4 corners, Anthony's uncle breaks it apart a little bit differently. Okay. So with this, he says, let S represent the length of one side of the pool. And then T represents the number of tiles in the pool's border. So that's what we've been doing. Okay. But he wants us to write a model that represents his uncle's, they want us to write an equation to represent Uncle Taj's model. Okay. So we know when it comes down to it that we've got T is going to equal something times something. But we don't know what all that something is going to be. Okay. So remember, S is the length of the side. So let's look here. Can we tell the length of the side here? Yeah, it's 1. And what exactly is he multiplying that by? Can we really tell? Or, no? Okay, so I'm going to go look at this one. I'm like, okay, we got the different sides here. We're saying 4 times, this time his length is 2, and we're going to multiply it by 3. Over here, his length was 1, and we said the side and 2. So 1 to 2, 2 goes to 3, and over here, his 3 goes to 4. And again, so it's 4 sides. So I know that I have to multiply this by 4. And I know something else is going to go here. And again, we had our side, which was, in this case, 1. And then, but we multiplied it by the side plus 1, which is really 2. Okay. So here his side was 2, but he wants us to multiply it by 3. So 2 plus 1 gives us 3. Over here, we've got 3, and he wants us to really multiply by 4. So 3 plus 1 gives us 4. If you notice on each one, guys, we took the length of the side and added 1. Okay. So with this model shows us that we've got 4 times the side plus 1. That's what we have here, is the same as our equation of 4 times the sides plus 4. Okay. With this, guys, you may remember this, but this is an example of the distributive property. Whoops, you guys can't see that. Distributive. Okay, in which we distribute, meaning multiply the outside number into the inside. Okay, this distributive property of multiplication and we took it over the addition. Okay, I'm going to click through a couple pages to get us to page. We want to go to question number 3. Question 3 for me, guys. Question 3. Okay, so on this one now, they ask us to explain the number of tiles in the border of a pool, to explain why the border of tiles of the pool is the same as the area of the border. Okay, why is the number of tiles in the border of the pool the same as the area? Now, some of you guys may be thinking, well, wouldn't the tiles around the pool be the perimeter? Okay, if you guys remember back, you may want to write this down. Perimeter means the outside, all the sides added up. Okay, area is the inside. Okay, now the one thing to note, okay, they say explain why the number of tiles in the border of the pool is the same as the area of the border. Okay, well, here's the thing though. The area, but they're asking, I said area is the inside. They're saying area of just the border. So we're not even going to worry about our inside. So if it helps, guys, you can cross those off. We don't need those. We're not looking at those. They will again want to know why the number of tiles in the total border is the same as the area of just the border. Okay, well, there's several different reasons we can think of this. Okay, the first reason being, I'm going to put this down here for you guys. The first reason is that each tile is a square. That's 1 foot. Meaning the area of a square equals 1 square foot. Okay, so again, the length of the side is the same as the area because 1 by 1, 1 times 1 is 1 area. Length times width means 1 foot times 1 foot, which equals 1 foot. Okay, another reason, or to kind of expand on this, is that the first pool has 8 tiles. Has 8 tiles, okay? Again, since the area of the tiles is 1 square foot, the area of the border would be 1 foot times the 8 tiles, which equals 8 square feet. Okay, going with this, with the second pool. The second pool has 12 tiles. So we're going to say 1 square foot, the length of it, times the 12 tiles gives us 12 square feet. My third pool, the third pool has 16 tiles. So we're going to say 1 foot long by 16 tiles total gives me 16 square feet. Okay, so again, let's go ahead and turn our page. Flip your page over. Okay, we are on to question number 4. Trying to catch myself up on Agile Minds here. So they want us to explain in words why s plus 2 squared minus s squared, whew, that's a lot, equals all of this, which equals that. Well, this is a lot to deal with, guys. So what they're trying to tell us is that with our biggest picture here, okay, there's a bunch of different explanations. So let's just start going through this a little bit. What they're saying is they want us to take apart each one of these. We know that a side in this case was just S. My side here was 2 things long. My side here was 3 things long. Okay. So with that, they're saying S plus the 2 corners, S plus the 2 corners, S plus the 2 corners, and S plus the 2 corners. Okay. That's a whole lot. In fact, guys, I don't like you even thinking this way. So we are actually going to cross off number 4. Okay. What I do want you to know with this, how they expanded this out, what S plus 2 squared means, do not, I'm going to put this in purple, saying do not do equals do not do this. Do not distribute that. No, 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 no. I'm going to put a big sad face. Okay. You may have done something like this already in previous years, but probably not. What that means, S plus 2 to the second power, what that really means is S plus 2 times S plus 2, in which we have to what we call double distribute. Some of you guys may know it as biology boxes, the Punnett squares. What this actually comes out to is S squared plus 4S plus 4. But then they include in here minus the S squared. Let me put that on here. Minus S squared minus S squared. So I'm going to drop that down to minus S squared. S squared minus X squared means they're gone, and I am just left with 4S plus 4. So we can see that this big, long, ugly problem that they gave us the same exact problem that we had before. That's why I don't want you guys to worry about that one. We're moving on. That's way too, they overdid that one. Okay. So question 5 here. Question 5. With this one, they just want us to evaluate the expressions at our assigned number. And what I'm going to do here, guys, is we're just going to give you some examples. Okay. Each one can be changed this using different stuff. So with this, guys, we're just going to pick a number that we haven't done yet. So I'm actually going to say that the length of my sides, in this case, equals 5. So we're going to go through and show each one of these. And I'm going to say, I'm going to show you where I'm plugging that 5 in. So my T equals 4. That is where my S is going to go, plus 4. So I'm going to say my 5 goes here. Writing this problem out, this would say T equals 4 times my S plus 1. And again, the 5 goes where the S is. And right here, we're going to say T equals my 5 plus 2 squared minus something squared. And let's go ahead and fill that 5 in here also. Now for each of these, to kind of solve them, we're going to follow our order of operations. So guys, on this first problem, this is multiplication. Multiplication comes before addition. So here I get T equals 20 plus 4. So my total tiles here, if I had a length of 5, would be 24. Let's check on this one. Order of operation says that we do parentheses first. Okay, so here I get T equals 4 times 6. 4 times 6 equals 24. So here they're the same. And on this last one, okay, again, parentheses comes first. So T equals 5 plus 2 is 7. squared minus 5 squared. So let's do each one of these here. T equals 7 squared means 7 times 7, which is 49. And 5 squared is 5 times 5, which is 25. And 49 minus 25, surprise, surprise, it equals 24. The big reason for me showing you guys this is that we see that 1, 2, 3 different ways we could write the same equation and they all come out the same. So there's not always one right answer. Does it all get us the correct answer? Yes, but there's more than one way to do things. Okay, and that's it for